Alright, so we're multiplying and dividing monomials. So this whole front page, we are learning how to multiply first. So, when we are multiplying monomials, or powers with the same base, okay, this means that we will have exponents. So when we're doing that, we are going to add the exponents, okay? So, when we have powers with the same base, we are adding the exponents. They have to have the same base or you cannot add the exponents, okay? So if you look at this box right here, it gives you an example of what we're talking about. If I have a to the m times a to the n, what term is my base? What is it? A. My a is the base because the m and the n are what? Exponents. Okay, so since they have the same base, that means I can add those exponents. Okay, so if you plug numbers in there, 4 squared times 4 to the 5th, I have the same base of 4. So that means I can add those exponents. Okay, so I have 4 to the 2 plus 5, which gives me 4 to the 7. Which then I could go further and I could actually calculate that if I needed to. Okay. Let's look at another example on A. I've got 5 to the 7th times 5. Anytime that you have just a number by itself, what type of exponent does it have? A 1. So this is like saying 5 to the 7th times 5 to the 1st. Okay. So since I have the same base of 5, that means I can add those two exponents. So 5 to the 7 plus 1, which gives me 5 to the 8. Okay. So all you're doing is adding those exponents, but you have to have the same base. All right, and B, I've got 7 cubed times 7 squared. So this kind of explains why I can add those exponents. If you think about 7 cubed, what does that mean? What does it mean to be 7 cubed? 7 times 7 times 7. So then if I multiply that by 7 squared, that means I have 2 more 7s. How many 7s do I have there?
A lot.
5. So I get 7 to the 5th. Okay. Which is the same as if I just add those exponents. 7 cubed plus 7, or times 7 squared, that gives me 7 to the 5th. Okay. So if you break it down as to what it actually means, that helps you to see why can I add those exponents. Okay. Questions about that? A, I've got g to the 3rd times g to the 6th. So again, I have the same base of g, so I can add those two exponents together. Example B is a little bit different because I have numbers. What are these numbers called? Do you remember? A number out front of a variable? Coefficients. So I have a coefficient of a 2, and I've got a coefficient of 3. So I want to multiply those coefficients, okay? So that means I can do 2 times 3, and then I can't forget about those a's. I still have a squared times a, which, do I have the same base here? Yes, so that means I can add those exponents. So when I simplify all that, I should get 6a cubed. Okay. Or, like before, you can write out exactly what it means. So 2a squared means I have 2 times a times 3a, which would be 3 times a. And once you combine those like terms, so 2 times 3, you still get 6. And then how many a's do I have? 3, so it's a to the 3rd power. Okay. Any questions? So anytime that you have coefficients, all you are doing is multiplying the coefficients, and then the common base is whatever variable you have. Okay. All right, example 1. 4 to the 7 times 4 to the 6. Do I have the same base? Yes, so that means I can say 4 to the 7 plus 6, which is what? 4 to the 13th power. About number 2. V to the 5th times V to the 4. Do I have the same base? Yes, so I can say that it's V to the 5 plus 4, or V to the 9th power. What about number 3? What do those parentheses mean? Multiplication. So this is the same thing. Do I have the same base? Yes, so I can say f to the 3 plus 9, which gives me what? F to the 12th power. Any questions so far? Number 4, I've got a negative 31 to the 4th times negative 31 to the 2nd. Do I have a coefficient? I can though, right? I have negative 31 to the 4th. Could I say that negative is a coefficient? So what would it say? What would it be like if I said negative 1 times negative 1? It would give me a positive 1, right? So I'm going to change this whole thing to a positive 31 to whatever power. Because two negatives make a positive. And since they're the same base, I can add those exponents, right? So I should get 31 to the 6th power. So anytime you see 2 negatives, your final answer is always going to be a positive. Or if you see 1 negative, 1 positive, then what's your final answer going to be? Negative. Number 5, negative CR to the 5th times negative R to the 2nd. So what do I know? Is my answer going to be negative or positive? It's going to be a positive. But what am I doing with that C? Do I need to do anything with it? No, I don't have another C there with an exponent to add, right? I just have one C, so it's just going to stay the same. I don't have anything to do with it. So I'm still going to have C times my R to the 5 plus 2. So what is it? CR to the 7th power. Okay. Any questions about that one? Number 6. Got 22 to the 5th times 22 to the 5th. So do I have the same base? Yeah, so can I add the exponents? Yeah, so what's my answer? 22 to the 10th power. Alright, what about number 7? I've got 7h times 5h to the 3rd. Do I have any coefficients? What are they? Coefficients. Remember, coefficients are those numbers out front. So what? 7 and 5. So can I just multiply those? Can I multiply coefficients? Yeah, the coefficients don't change. You still got 7h times 5h to the 3rd. So you still have 7 to the 5th. 7 times 5. Okay. So you're multiplying your coefficients just like normal. Your variables with exponents, your monomials, are the only ones that are changing. So I've got an h and an h to the 3rd. So what does that mean? H to the 4th, right? Because this h has an exponent of 1. So that means I've got h to the 1 plus 3. So what's 7 times 5? So I have 35h to the 4th. Don't assume that there's a 0 up there. That should be a 1. Okay. Alright, what about number 8? Do I have coefficients to multiply? Yes. Negative 10 and 7, right? So what is negative 10 times 7? Negative 70. And then do I have the same base? So I can say negative 70x to the what? 5th power. Any questions? Alright, let's skip over to number 12, since it has 3 terms. I've got 9z cubed times 2z times negative z to the 4th. So the first thing I'm looking at is my coefficients. So I've got a 9, a 2, and a negative 1, correct? So I can just multiply all those together. And then, do I have a common base? Of what? Z. So, since I do have a common base, that means I can add all of my exponents. So, 3 plus 1 plus 4. So, what's 9 times 2 times negative 1? Negative 18. And z to the 8th power. Whoops. What's wrong with Z? So, what do you notice about, like, when do you know to multiply the coefficients? Huh? When they're different. Okay, I'll take it. But, like, comparing number 6 and number 12, why didn't I multiply my 22s? Because those are the bases. Okay, so you never multiply the base. You just always multiply your coefficients. Okay, so since these have a coefficient and a base of a variable, I'm just multiplying the coefficients and the base stays the same. Just like if I have a base of a number, that base of that number is staying the same. Okay. What if I had this problem? A times b to the 5th times 8a squared times b to the 5th. What if I had that? What's the first thing that I need to look for? Okay. Madeline. My coefficients. So what are my coefficients? 8 and 8 and 1, right? So you're just multiplying the 8 times 1. And then what about my A's? Do I have a same base with my A's? Yeah. So I can combine the A's. So that means I really have an a to the first, right? So I say a to the 1 plus 2. And then do I have the same base of a b? Yeah. So I can say I have b to the 5 plus 5. Which all comes out to be 8 times a cubed times b to the 10th. So just break it apart into pieces. Look for coefficients first, and then look for same bases. Questions on multiplying? Hey, what's the opposite of multiplication? Division. So if I am multiplying monomials and I add the exponents, what do you think I'm going to do if I'm dividing monomials?
Subtract them.
I'm going to subtract them. So exact opposite. Okay. So if I'm dividing powers with the same base again, that means I'm subtracting the exponents. So if I look at this, I have a to the n divided by a to the n. What's another way that I could write that without other than fraction form? This mean the same thing? Yes. So whether you see it in fraction form or with an actual division sign, you are still doing what to those exponents? To the exponents. Subtracting them. You are still subtracting the exponents. Okay. So I have 5 to the 6th divided by 5 to the 2nd. So since I have the same base of 5, that means I can say 5 to the 6th minus 2, which equals 5 to the 4th. So you're subtracting the bottom number from the top. Okay. Alright, so A, I've got negative 8 to the 4th divided by negative 8 squared. Do I have the same base? Do I have the same base? Yes, negative 8. So can I subtract the exponents? Yes. So I've got negative 8 to the 4 minus 2, which gave them negative 8 to the second. But can I go ahead and simplify this a little bit further? To what? What about those two negative signs? Could they change to a positive? They could. Okay. So I could say that this is positive 8 squared, because you're dividing a negative and a negative, which would give you a positive. All right, example B, a to the 7th divided by a to the 3rd. So I still have that same base of a, so I can subtract those exponents. So a to the 4th. Okay. So the only thing that changes is you're subtracting instead of adding. Example 2 is actually a word problem. And we are trying to compare distances. So the Mississippi River is approximately 3 to the 7th miles long, and the Kentucky River is approximately 3 to the 5th miles long. About how many times as long as the Mississippi River than the Kentucky River. So I can write those exponents as the division law. So when I simplify that, it gives me 3 to the 2nd. And then, of course, 3 to the 2nd is 9. So that tells you that the Mississippi River is approximately 9 times as long as the Kentucky River. Remember, if it specifies in your directions to express the answer as an exponent, then you are going to want to keep it as that 3 to the 2nd power, which is exactly what they say right here. Express using exponents. So that means in every single answer, you should have some type of exponent. All right, number 1. 7 to the 5th over 7 to the 2nd. Do I have the same base? Yes. So what can I do with the exponents? Subtract. So 7 to the 5 minus 2, which equals what? 7 to the 3rd power. Good. About number 2, do I have the same base?
Yes.
So I can subtract. So 1 to the 8 minus 6, which is 1 squared. About number 3. Do I have a coefficient?
Yes.
I have 2 negatives right there, right? So a negative divided by a negative, a positive. So I can go ahead and say that this is positive 12 to the 3 minus 3. And what is 12 to the 3 minus 3? 12 to the 0 power, right? 3 minus 3 is 0. Is 12 to the 0 power the same as 12?
No.
Absolutely not.
No.
What is anything raised to the 0 power? 1. Anything raised to the 0 power is 1. So this actually would equal 1, but they want us to express it as exponents, so we're going to keep it as 12 to the 0. Which, you could already look at that and tell, because what if I had 2 divided by 2, what would that give me? 1. What if I had 20 divided by 20? 1. Is negative 12 cubed the same as negative 12 cubed?
Yes.
So you're dividing the same thing by itself, so it has to give you what? 1. So therefore, 12 to the 0, which equals 1, makes perfect sense. Okay. What, Elliot?
Something I also find interesting is when there's like, say, 10 to the something power, the power basically is what 1 with that many zeros on the end of it.
With 10, only with a base of 10.
Yeah.
Yes. Okay. Number 4. C to the 20th divided by C to the 13th. So what would this be? What's 20 minus 13? 7. So this would be C to the 7th. Number 5, I've got a negative P to the 18th divided by negative P to the 12th. So what you think? What would this be? P to the 6. And it would be a positive P, right? Because you got a negative divided by a negative, which is giving you a positive. All right, number 6. Now I have a coefficient, right? 2w cubed divided by 2w. So I want to look at those coefficients first. What would I get when I divide those coefficients? 1. 2 divided by 2 would give you 1. And then you've got your exponents. So w to the 3 minus 1. So how would that all simplify? Just w to the second, right? I don't need that 1 there. So just like the multiplication, you can simplify the coefficients, but not the, so if you have a number as your base, like number 2, you're not simplifying 1 divided by 1. Okay. But here I've got coefficients, which I can simplify those coefficients. Let's look at number 8. K to the 9th over K. What do you think that would be? Yeah, K over 9 minus 1. What? K to the 9 minus 1? Yeah, this K on the bottom, what does it have an exponent of? A 1. So that means this would be K to the 9 minus 1, which would be what? K to the 8th. You have to remember that if you just have a single number, that it is raised to the first power. All right, what about if I have this problem? N cubed times n to the 5th divided by n squared. What's the first thing I'd have to do here? Solve the top, right? So what is n cubed times n to the 5th? Right. I'm multiplying, right? So when I multiply monomials, that means I'm adding those exponents. So it'll be n to the 3 plus 5 over n squared, which would give me n to the 8 over n squared. And then what would all that simplify to? N to the 8 minus 2, which would be what? N to the 6. Any questions about that? Any questions about multiplying and dividing monomials at all? Not too bad, right? So if I'm multiplying, what am I doing to those exponents? Adding. If I'm dividing monomials, what am I doing with exponents? Subtracting. Your homework is written at the bottom of your page. So you've got page 497, numbers 10 through 35, 38, and 40. You should be able to finish this before you leave.